Play 1 and Play 2 Rainbow Lights in Space. In this chapter, you create a cool-looking animation, a rainbow weed that flies through space and leaves colorful trails behind. This program was inspired by the emotions by subculture of artists, programmers who made amazing graphical programs starting in the 1980s. The Moskner is made beautiful elaborate program called demos that show the artistic, musical, and programming skill. But most amazing of all, this program was tiny, just like a few kilobytes. The program isn't quite as small, but it's dramatic and colorful. And it uses only a few lines of script code. Before you start coding, look to playing video to see what final program will look like. Just like the Moskner, you can make beautiful programs that create your own graphics demo in Scratch. Sketch out the design. The first step of turning an idea into a Scratch program to sketch out what you want it to look like. Turning to your program helps to figure out the sprites you want and how they behave. In recommend drawing your ideas on paper so you can cross them out if you don't like them and write down notes and reminders. It's also best to keep projects simple. When you complete the simple game, you can build on it to add complexity, which is idea behind integrative development. First, you make a program work, then you make the program base. You can always add cool things to the basic program after you finish it. Don't worry about making the shape look nice. It's more important to have a solid plan for the main part of the program. In my sketch, I have 3 parts, A, B, and C. We will work on this part until we build full program. A. Create the space black background. B. Create the 3 bouncing dots. C. Draw the rainbow lines. After you complete the sketch you want to program to, you can start programming. Go to https://mit.edu. Sign up for an account on the site if you haven't already and log in. Having an account lets you save the program on Scratch website. After you log in, click the Create button at the top of the screen to start making the Scratch project. Then click the text field at the top, change the name of the project from Entity to Rainbow Lights. Let's begin by tackling part A of the sketch. Create the space background. First, let's clean up sprite we want use. Set the background. Clean up and set the stage. Every time you create a new Scratch project, you can see an orange and text sprite on a blank white stage. We don't need the sprite for our program, so right-click the sprite one card in the sprite list and either select Delete to remove the card from the stage and sprite list, or click the touchscreen and connects the sprite. Click the Choose a Backdrop button, which looks like a landscape painting, and the new backdrop. Choose a backdrop. The backdrop library window will open and display all the backdrops and particular. Click the Start Backdrop. 1. Make sure all is selected or Start Backdrop will show up. 2. Select the Start Backdrop. Now the straight backdrop looks like our space. Create 3 bouncing dots. Next, we add 3 sprites and we represent the 3 points of the flowing V. Paint the dot. Click the paint button, which looks like a paintbrush. Paint a new sprite named Sprite 1 is created in a sprite list. Click the button. Also switch the editor to the Custom tab, which contains the paint editor. Use the brush tool. Draw a small red dot near the crosshair. In the paint editor, it might help to zoom in by clicking the zoom button, which looks like a magnifying glass in paint editor. Brush tool. Zoom pattern. In the sprite pane above the sprite list, change the sprite name from Sprite 1 to Dot 1. Type the new name here. Add code for the Dot 1 sprite. Now we can start programming. Click the Code tab to make the code area visible, and the flowing code to code area. You can find this plot in even, yellow, motion, dark blue, operator, green, and control light orange categories. When green flag click point in direction, pick random minus 118 to 118. Forever, move 10 steps if on edge bounce. When you click the green flag, the dot 1 sprite in the random direction between minus 118 and 180 degrees. Then forever, you move the sprite forward 10 steps and make the sprite bounce when it hits the edge of the stage. The sprite will continue to do this forever. Notice the dot sprite isn't drawing any rainbow lines yet. We do that after we create more sprite. Explore direction and degrees. Words like a right perfectly understood as direction by human like you and me, but the computer needs a number indicate an exact direction. All sprite inscribe have their own direction number. The direction numbers are between minus 180 and 180 degrees. Pointing at 0 degrees is facing up. Pointing at 19 degrees is facing to the right. The flowing figure shows several directions and the degrees. Notice that the degrees increase in the clockwise direction and decrease in the counterclockwise direction. Also notice that minus 180 and 180 degrees point in the same direction down. Pick random minus 180 and 180 plot to the random number to give us the direction. Then the point in direction dot points the sprite in that direction. This means that the sprite could be pointing any possible direction. Let's write a new script that demonstrates degree work on a new tab by pressing Ctrl T in your web browser and go to https://mit.edu to open the new script editor. You can edit multiple script programs at the same time. In the code area for the class branch name sprite1 and the following code using block from the event yellow, control light orange, motion dark blue, and look purple categories. Keep in mind that we're writing the totally separate program from the Rainbow Lights program. When green flag click forever, point towards mouse pointer, say direction. When you turn this program, the sprite point towards the mouse, the code will say the direction in which it's pointing. Notice that the direction number changes as the cat direction changes. Duplicate the dog1 sprite. Right click the dog1 sprite in the sprite list and select duplicate. To do this twice so that you make two duplicates, .2 and .3 script automatically. Name the sprite will increase numbers. Save point. Click the green flag to test the code so far. Check that all three dots are moving and bouncing around the stage. When you duplicate the sprite, you also duplicate the sprite code. Click the red stop sign and save the program. Draw the rainbow lines. Now that we create all the bouncing dots, we can create a 4-dot sprite to draw the rainbow lines. We write a program that makes these drawing dots move quickly during the 3 bouncing dot sprite, drawing a line as it moves. The process to repeat 3 times, and then after 10 seconds, the screen will clear. Add the code for drawing dot sprite. This project uses pen code blocks, which are not included in the block palette by default. You must click the Add Action extension button in the lower left corner of the editor and select pen from the window that appears. Right-click one of the bouncing dot sprite and select duplicate because this is the duplicate of the bouncing dot. It has some code we need to delete. In its code area, delete all the code block by dragging the green flag, click block, and run the block underneath it. The block palette in the middle editor where they disappear. In the side bracket, we name this sprite drawing dot. At the flowing tool, click to drawing dot sprite. You can buy this block in the event yellow, pen clear, control, light, orange, and motion dark blue categories. Remember the pen code blocks appear only if you click the attention button to select pen. As in script 1, make sure you go to block, not go to AE block. Also be sure to change the go-to block of the ongoing to the mouse pointer. To do so, click the white triangle on the bar and select the sprite from the menu. Before you run the code, let's talk through how it works. When you click the green flag in script 1, the drawing dot sprite runs the area or block to clear any pen drawing already on the stage. Then sprite runs the pen down block. As the sprite moves around, it draws the line on the stage to better understand what the panda block does. Imagine holding down a giant marker on the floor while you walk around it. The marker will draw a line on the floor following you. The drawing dog goes to dog 1, proceeds panda goes to dog 2, and then goes to dog 3. Makes the chain pen color by 10. Block change the color of the pen slightly. You can increase this number to make the color change faster. At the same time, the dog 1, dog 2, and dog 3 will continue to move around the O, so the V line that the drawing dog will also move around. Script 2 is a lot simpler to understand. This code waits 10 seconds, then create a screen of animal made by the pen blocks. As the stage 1 become overcrowded with rainbow lines. Save point. Click the green flag to cast the code so far. You should see a flying rainbow moving across the stage. Then every 10 seconds the rainbow clears. Click the red star sign save. The complete program. The final code for the entire program is shown here. Notice the code for the dog 1, dog 2, and dog 3 sprite is identical. If your program isn't working correctly, check your code against this code. Turbo mode. If you hold Shift while clicking the green flag, you can start the program in turbo mode. The computer is usually able to run code block quickly. For the program that draws sprites, the screen slows down the computer. In turbo mode, instead of drawing the screen after each code block, scratch to the screen only after several code blocks. Human eyes won't notice the skip drawing, and then program will look like it's running faster. Shift-click the green flag to run the regularized program in turbo mode. Almost instantly, the screen fills up the end turbo mode. Shift-click the green flag again. Summary. In this chapter, you build a project that has custom sprites you create, even if they are just dots. Use the pick random block to point the sprite in random direct. Make sprite move when bounce the edge of the stage. Duplicate sprites in the code. Use the pen block to draw rainbow lines. This project is a demo that user can watch but can't control. In chapter 3, you make a maze script that let player interact with the program by using the keyboard. It will be the first real game project in the book. Review question. To try to answer the following practice question to test what you've learned. You probably won't know all the answers to the top of your head, but you can explore the square editor to figure out the answer. What happens when the sprite moves after it has sprite pen down block? If some code moves the sprite but no line is drawn behind it, what might cause this problem? Which block causes the lines in the rainbow lights program to look like a rainbow? Which code could you use to make the rainbow lights thicker? How do you turn on turbo mode? How do you turn it off? How do you duplicate the sprite in its code block. Write the sprite point when its direction is 19 degrees. What is the degree direction for pointing up? You want the sprite to point down and move in the direction in which color the block category would define code block to do this. How do you select a new backdrop from Scratch backdrop library? You see a sprite next background in the sprite list. How do you rename this sprite? Goodbye everyone.